In section 4.2, our objective is to add and subtract polynomials. Before we add and subtract polynomials, we want to get a few of the vocabulary terms out of the way. A monomial is an expression that is either a numeral, a variable, or a product of a numeral and one or more variables. So an example of a monomial could be just a regular number such as 14, a variable such as z, a combination or a multiplication of a number and a variable such as 2/3 r, or a number 6 times multiple variables that have exponents on them. So negative 6x squared y. This right here, this monomial, has a special name when it's just a number. It is called a constant. The next word we need to talk about is a polynomial. A polynomial is a sum of monomials. So an example of this could be x squared plus negative 4x plus negative 5. Notice it's a sum of monomials. Now, the book's actually going to simplify this. They're not going to use the addition signs. They're just going to go ahead and write this as x squared minus 4x minus 5. Now, there are a couple special names for polynomials. If there are only two terms, it's called a binomial. So a binomial could be something like this, 6x minus 7. And notice that has the two pieces, and that's where the word binomial comes from. The next special polynomial is a trinomial. And a trinomial is going to have three pieces, like the prefix tri implies. So above here, this would be a trinomial, but we can write another one. Let's say I have 2x squared plus 9x minus 3. Once again, it has three pieces, so that makes it a trinomial. The next word we need to talk about is coefficient. And a coefficient is the number in front of a variable when we have a monomial. So if I had negative 3x squared y, negative 3 would be the coefficient of this monomial. So a coefficient is the number in front of the variables when we have a monomial. We also need to know what like and similar terms are. Two monomials that are exactly alike or are the same except for their numerical coefficients are said to be similar. So for example here, this would be a list of similar terms. Negative 5xy squared, 16xy squared, xy squared, and 1/3 xy squared. Once again, these are all alike or similar because they have the same variable part. We are not worried about the coefficient part when we are talking about like or similar terms. We're just worried about the variable part being exactly the same. Now, let's get into some example problems. In example 1, they're going to give us a polynomial here, and they want us to simplify it. Okay, a polynomial is simplified when there are no like terms that are not combined. So right here, what we want to do is to combine like terms. So this negative 3x squared and this x squared are alike, so I'm going to go ahead and write them next to each other. This positive 5x and this negative 2x are alike with each other. And then this constant of a negative 4 doesn't have another like term with it, so I'm just going to slide it to the back here. Now, after I do that, I'm going to find the sum of the like terms. So right here I can slide a 1 in front of this x squared, and then I figure out what negative 3x squared plus 1x squared is, and I just add the coefficients, and then the x squared gets put in the back here, so that is negative 2x squared. Now I'm going to do a positive 5x minus a 2x. So once again, I'm just going to do what it says for the coefficient. So positive 5 minus 2 is going to give me a positive 3x. And then this negative 4 does not have a like term with it, so it just gets brought down. And then this is my answer to the simplified polynomial. Negative 2x squared plus 3x minus 4. In example 2 here, it's going to be very similar. It says to simplify, so once again I'm looking for those like terms. So I have a 4m squared and a negative m squared, and so I'm going to put these next to each other. I have an mn squared and an mn squared, so I'm going to put those next to each other. Now, after I get those, I'm going to go ahead and combine the like terms. So once again, if a monomial in this does not have a coefficient number, I'm going to go ahead and slide a 1 there. So 4m squared minus 1m squared is 3m squared. And then right here, I need to combine these two together. I have a positive 5mn squared added with a 3mn squared is an 8mn squared, and then I will go ahead and combine those two, and this is what I get right here. In example 3 here, it says write the sum of the areas of the rectangles in simplest form. So pretty much what I want to do here, I want to take the area of A plus the area of B plus the area of C plus the area of D. Okay, so to do this, we all know to find the area of a rectangle that we multiply the length times the width. So for the area of A, I'm going to do 5x times 2x. And I'm going to add to that, the area of B is going to be 5 times 5x plus the area of C, I need to do 2x times 2x, and then the area of D, I need to do 5 times 2x. Now, from 4.1, we talked about multiplying with exponents, so we're going to go ahead and use those rules. So here I need to do the coefficient times the coefficient, so 5 times 2 is 10, and then the variable times the variable, x times x gives us an x squared. Plus, here, the coefficient, or the number here, times 5 is going to be 25, and then the x comes down, plus, now I need to do 2 times 2, which is 4, x times x is x squared, then I have plus 5 times 2 is 10, and then I bring the x down with it. Now, after that, I need to go ahead and add the like terms. So those are alike, so I'm going to put them next to each other, 10x squared plus 4x squared. And these two are alike with each other, so I'm going to go ahead and put those next to each other. Now, I just combine the like ones. These two are alike, so 10x squared plus 4x squared is going to give me a 14x squared. Then I need to do this. I have a positive 25x plus 10x is a positive 35x. Okay, if we want a label for this, we could just put units squared. It didn't tell us, okay, what each side's measured in, so we're going to go ahead and just label it in units squared. In this one, it says find the degree of this monomial. Okay, what the degree is the sum of the degree of each variable. So to help me explain this, I'm going to go ahead and name the degree of each variable. So the degree of x is equal to 3. All you have to do to find the degree of a variable is look at the exponent on that variable. Now, I am going to find the degree of y. The degree of y is 1. Anytime a variable does not have an exponent on it, it's implied that it's a 1, because y to the first is equal to y, so the degree of y is 1. Now we need to find the degree of z, and the degree of z once again is 3. Okay, so those are the degree of each variable in the problem, but the question of this problem is to find the degree of 4x cubed y z cubed. So the answer to that, the degree of 4x cubed y z cubed, what we do is we just add the degree of each variable. So to find the degree of 4x cubed y z cubed, I take the degree of x, which is 3. I add to that the degree of y, which is 1. And then add to that the degree of z, which is 3. And then I get 7. So the degree of 4x cubed y z cubed is just 7. Now, in example 5, it just wants us to add these. In this, the parentheses are really extra. The reason the book or this problem's written is we're saying this is one polynomial and this is added to it. The parentheses just let us know that each one of these are individual polynomials. So really what we need to do here is just to simplify like terms. So I have a 2a squared into 4a squared, so I'm going to get those together. Then I have an ab into negative 3ab, so I'm going to get those together. And then I have a 2b and a 9. Those are not alike. I know I circled them, but they're not alike. But since they don't have any other like terms with each other, I'm just going to bring them down individually. And I'll make them different colors here to make it clear that these are not alike. Let's erase that to make sure that doesn't look like a 9. Now I just add the like terms. So 2a squared plus 4a squared is 6a squared. This ab doesn't have a coefficient, so I can slide a 1 there. So I'm going to go ahead and combine these. 1 minus 3 is a negative 2. And then I have ab. These two are not alike, so I'm just going to bring them down. So I have a plus 2a and a plus 9. So right there, that is my solution when I add those two polynomials together. In example 6 here, it says to subtract. So once again, these two polynomials have parentheses around them to tell us this is one polynomial, and I'm going to subtract this. Now, this time we're subtracting this whole second polynomial, so we got to be careful with the signs on this. So when I subtract, what I like to do is when I like to distribute this negative through and go ahead and switch the sign. So when I distribute that negative through, I'm going to have negative times 5x squared is negative 5x squared. Then I have negative times a negative, which is going to be positive y squared. Now, when I distribute this, I really don't need the parentheses anymore. So the second one, notice all that happens is the sign changes. And now, this first one, I'm just going to bring straight down. So be careful when you have a subtraction problem here. You're going to distribute the negative. So negative times 5x squared was just the negative 5x squared, and then negative times negative y squared would give me a positive y squared. So now, after I get rid of that negative in the parentheses there by distributing, I'm going to go ahead and combine the like terms. So I have a 5x squared and a negative 5x squared, so I'm going to write those next to each other. I have a positive 7xy, and there's no other xy terms, so I'm just going to bring that down. And then right here I have a positive 2y squared and then another positive y squared, so I'm going to write those next to each other. And now I'm just going to combine the like terms. Now notice we have 5x squared minus 5x squared. Just like if we did 6 minus 6, we would get 0. Over here, 5x squared minus 5x squared is just 0. So I'm going to go ahead and cancel these out. Since they're worth 0, they're not going to change the value of my problem, so I'm just going to cancel those out. Now I have this 7xy. It doesn't have any like terms, so I'm just going to bring this down, and then since it's out front, I don't need that positive or plus sign anymore, so I'm just going to get rid of it. These two right here are alike, so I have a positive 2y squared and plus a y squared. Remember, I could slide a 1 here as the coefficient, so positive 2y squared plus 1y squared is a positive 3y squared. Those are the example problems and vocabulary terms for section 4.2 over adding and subtracting polynomials. If you have any questions, go ahead and come to class and ask them. I'll be more than willing to help you.